Welcome. In this session, we'll briefly explore the concept of a level set. Let's begin by recalling a level curve. So we can recall that a level curve, of a function that has a vector argument at a level, and we picked the script L, is defined as, and we used this double-barreled S and we put a C subscript because we were talking about a level set. So this is of a function at a level, and that is defined as the set of all arguments in the vector space such that the function evaluated at that argument exactly equals the level. And these level curves are how we draw contours of functions that have vector arguments of size 2. And we can think of a level set, and we can think of that as a filled-in level curve. And the definition is really similar. So let's take care, because when things look the same, we have to pay attention to those small differences. We'll say that a double-barreled S with a subscript L for level set of a function at a level, we will define that as the set of all vectors such that the function evaluated at that argument is less than or equal to L. And so the only difference between these definitions is that here it's an equality and here it's an inequality. And that makes all the difference, because what this does is it effectively fills in the level curves. Now, that filled in is in quotes, because what does it mean for a function to get filled in when its contours are non-convex curves, when they're sort of curvy, messy curves, which we've seen often in the functions that we look at. So what we'll do is we'll use level sets only of convex functions for the most part. Let's go through some computer-generated examples. Suppose we take that affine map, function 1, and we look at it at level 0. So the function was affine, and if it's at any level, we can see that if we pick some constant level and intersect that level with this tilted plane, we'll get a line. And so what does the level set look like? Well, it means that when we cut it at that level, that any vector argument that is at that level or is less than that level is going to be in the level set. And so what that will look like is this line is where this affine map is at level 0. So that line describes all of the vectors that when their arguments for this function produce a level of 0, and all of this shaded area are arguments that produce a level that's less than 0. So that's how I generated these convex sets, is I generated them as level sets of a convex function. Now, let's take function 4. So function 4 was that elliptic paraboloid, or that squished bowl. And if we take that squished bowl and we cut it at any level, then we're going to get an ellipse as its level curve. And what will happen when we look at the level set is the level set will fill it in. So whatever level we pick, any vector argument that produces a level equal to or less than will be in that level set. And that has the effect of filling this in. And so we're starting to get this idea, which is a theorem that you can certainly find in in lots and lots of optimization work is that the level set of a convex function is a convex set.